right now, on this phone and the one in your pocket. Every Android, every Mac, every Tesla. The Airbus A350 you flew on last month. The space station overhead. There is one piece of software running. The same software. More than 1 trillion installations. More copies than there are people on Earth. It is maintained by 3 people. They refuse venture capital. They refuse your pull request. They have written about 600 times more test code than the code they are testing. His name is Richard Hipp. He lives in Charlotte, North Carolina. And right now, every coding agent on the market is using his database as their working memory, while writing the code that may someday replace it. Year 2000, United States Navy. The USS Oscar Austin, a guided missile destroyer. On board, the database the ship's software depends on, Informix, keeps going down. When it does, every application that depends on it fails with it. Richard Hipp is the contractor they call. He works for Bath Iron Works, a subsidiary of General Dynamics. And he has a hypothesis. A database, he thinks, should not be a service that can crash and take everything else down with it. A database should be a library. Code that lives inside the application. That opens a file, reads it, writes to it, and is done. Like Fopen, not like Oracle. That same year, the federal government shuts down. Hipp's contract is paused. He uses the time off to write the database he had been imagining. He releases it in May 2000. No license, no copyright, no royalty, public domain from day one. He calls it SQLite. The ITE suffix is deliberate, like granite, like magnetite. Something solid, rooted. By 2001, Motorola ships the first phone with SQLite inside it. By 2005, Mozilla and Symbian have joined Hipp to form the SQLite Consortium, a small group of major customers who pay an annual fee in exchange for one promise: long-term maintenance with 0 royalties forever. And by today, 26 years later, that library, written during a government shutdown by one engineer trying to fix a database on a destroyer, runs on more than 1 trillion devices. Maintained by 3 people. Richard Hipp, Dan Kennedy, Joe Mustachkin. How does a library this important, running in your phone, your browser, your car, the cockpit of a fighter jet, stay reliable across 26 years and 1 trillion installations? The answer is not talent. It is not speed. It is not headcount. The team is 3 people. The answer is testing. Specifically, a kind of testing that almost nobody else in software does. The SQLite library itself, the part that ships in your phone, is about 156,000 lines of C code. The test code that verifies it is about 92 million lines. 600 to 1. For every line of code that ships, there are roughly 600 lines of code testing it. And it is not generic test coverage. The standard the team aims at is called Modified Condition Decision Coverage. It is the same standard the FAA requires for the flight software in a Boeing or an Airbus. What that means in practice, every conditional in the codebase has tests proving that flipping each input changes the outcome. Independently, there is no untested branch. There is no dead code. The verification is mathematical. Some of those tests are in the public repository. The most rigorous of them, the suite the team calls TH3, is proprietary. SQLite's commercial customers pay for access to it. The discipline pays the bills. And testing is only the front line of how this team thinks about correctness. Take provenance. SQLite is in the public domain, which means every line of code that ends up in the source tree has to be traceable to a person who has signed a physical affidavit dedicating that work to the public domain. Those signed affidavits are kept in a firesafe in Charlotte, North Carolina. Originals. On paper. And because of that requirement, the project does not accept pull requests from anyone. If you want to contribute, you write to the team. They might use your idea. They will rewrite the code from scratch to be sure of where every line came from. The version control system is also unusual. SQLite does not use Git. Hipp wrote his own, a system called Fossil, where Git allows you to rewrite history, to rebase, to squash, to make the past look cleaner than it was. Fossil refuses. Once committed, history is fossilized. Every decision, every bug, every fix is on the record. Forever. For software that runs in a fighter jet, that is the point. And then there is the detail that gets senior engineers, the one most people who have used SQLite for years still don't know. There is a mode you can build SQLite in where it never calls malloc. Not once. The library uses a static buffer that you give it at startup, and that is all the memory it ever uses. No heap allocation at runtime. No fragmentation. No risk of memory exhaustion. That is why this library, this small public domain database written by a contractor on a Navy job, is trusted in cockpits, in life support, in missile defense systems, in places where a memory allocation failure is not an inconvenience. It is a death. 3 people, 600 to 1 tests, no pull requests, affidavits in a firesafe, immutable history, and, when needed, a memory model so deterministic the database can run for decades without ever asking the operating system for another byte. That is the discipline. The lesson SQLite teaches is one the rest of the industry largely walked away from 20 years ago. When the open source movement won, it won on the back of a different proposition. Many contributors, fast iteration, move fast and break things. The bigger the community, the better the software. And for consumer software, for apps that need to ship features every quarter, that proposition was right. Linux, Chrome, the Node ecosystem, every modern web framework, all built that way. But infrastructure is a different job. Infrastructure has to outlast the people who built it. Infrastructure cannot break under load it didn't expect, in conditions nobody simulated, on hardware nobody tested. And the way to build software that lasts, the way SQLite has demonstrated for 26 years, is the opposite of the move fast model. Small team, long ownership, obsessive testing, no pull requests, no venture capital, no growth for its own sake. The discipline is the moat. And here is the part that proves it. SQLite is not invulnerable. In late 2018, a security team at Tencent, the Blade team, discovered a class of vulnerabilities in SQLite's full-text search extension. They named it Magellan. An integer overflow, a buffer overflow, remote code execution. If the attacker could feed crafted input through Chrome's Web SQL interface, which they could, on any website. The blast radius is what made it serious. Because SQLite is statically linked into thousands of applications, every one of them had to be patched independently. Adobe Lightroom, Dropbox, every Chromium-based browser. The list ran for weeks. But here is the part that matters. The team identified the issue, isolated the affected version range, and shipped the fix surgically. No emergency war room, no regression cascade, no backlog of unrelated tickets to clear first. 3 people with a 600 to 1 test ratio can patch faster than a 100 engineer team can hold a meeting. That is what the discipline buys. Now look at what is happening in software development today. Open Cursor, the most used coding agent on the market. Open the directory where it stores its data. Inside, you will find a SQLite database. Every conversation Cursor has with you, every reasoning chain, every multi-step plan it builds while editing your code, all of it is written into SQLite. The agent thinks in SQLite. Cursor is not unusual. The entire ecosystem of coding agents has converged on the same architecture, a 4-tier memory system. Episodic memory of past conversations. Semantic memory for relationships and concepts. Project memory for current edits. Procedural memory for rules of engagement. Almost universally, all 4 are backed by SQLite, which means the agents writing the code that may build the next generation of infrastructure, the agents that will, eventually, be tasked with replacing libraries like SQLite, those agents currently live, breathe, and remember on top of SQLite. They run on the discipline they themselves do not have. 600-to-1 test ratios. Affidavits in a firesafe. Immutable history. No pull requests. None of that survives in the way agents currently produce code. The agents on this database are writing thousands of new libraries every day. None of them have 600-to-1 testing. Will one of them be the next SQLite? And will we know before it breaks? 3 takeaways from the architect's lens. 1. Trust at scale is built by constraint, not contribution. SQLite stayed small on purpose. The discipline is the moat. 2. Every coding agent shipping today runs on top of a discipline it does not itself have. That is a borrowed foundation. We should be honest about it. 3. The next ubiquitous library is being written right now. By agents, without 600-to-1 testing. We will find out which one it is the same way we found out about log4j when it breaks. If this kind of breakdown is useful to you, subscribe. Until then, keep your foundation small.